This is a short video to help with some of the graphing that you are seeing in my math lab. Some students are struggling with how this tool works, especially when the answers that you get in this case, a linear equation, end up being fractions, and there aren't fractions on the scale of this graph, so it makes it a little bit confusing. What we're going to do is think about a different way to approach this problem to make sure that the answers we get are all integers or whole numbers. If I click this little button here to make the graph bigger, one thing to notice is that when you grab the line tool, you're going to scroll around, click on a point, and then click on a second point, and it'll draw the line. When you are scrolling around, in the right-hand corner, it shows you what point you're on. So if you want to make sure that you stop at a particular point, like 12.6, you'll see what it is before you click. This would be clicking on -14, -3. So again, this assumes that we have solutions that are whole numbers. Let me show you how to do that. This equation is x minus 4y equals 5. So let's write that. X minus 4y equals 5. It's going to be easier if I get this into slope-intercept form, in the form of y equals mx plus b. So I'm going to solve for y. Rather than just guessing two integer solutions that'll work, we'll move this around to make it a little bit easier. Let's subtract x from both sides. And then we'll divide both sides by -4. Now I'm going to leave this as a fraction like this, and here's why. This is going to be easier for me to graph if this is a whole number. So that means that I need the numerator to be a multiple of 4. Oops, I'm missing a negative sign. So the numerator needs to be a multiple of 4. So examples would be, what if I have -x plus 5 if I set it equal to 4? Or what if I said -x plus 5 is equal to 8? Or -x plus 5 is equal to 12. I'm just trying to find answers that will cancel with the -4 on the bottom and end up being a whole number. In this first example, we get that -x is equal to -1, or x is equal to 1. In the second example, we're going to end up with -x is equal to 3. So x is equal to -3. And for this third example, we'll have -x is equal to 7. So x is equal to -7. So rather than just plugging in any points to the original, let's plug in these three. Let's plug in 1, let's plug in -3, and let's plug in -7 to figure out what the corresponding y value is. So y equals -x plus 5 over -4. Let's let x equal -1. So we get y equals -1 plus 5. Oh, sorry, I think that was a positive 1. Sorry, my bad. We're letting this be +1, right? So that was not going to end up working. So y is equal to -1 plus 5 over -4. So we get -1. So one of the points on our graph is 1, -1. Our second option was x equals -3. X, let x equal -3. So y is going to equal -3, so +3 plus 5 over -4, which is 8 over -4, or -2. So another point on our line is -3, -2. And then for the third example, we only need 2, but I'm just doing 3 just to show you the process. If we let x equal -7, we'll have y equals, that'll turn into a +7 plus 5 over -4, which ends up being -3. So -7, -3 is another solution. So let's go back to my math lab. And I'm going to graph this using 2 of the points that I just found. I'm going to click on the line tool here, select 1, -1 is my first point. Let's see, 1, -1. I'm going to scroll until I see that in the upper right hand corner in the yellow, and I'll click when I'm on the right point. And then I'll use -7, -3 as the other point, just because they're a little bit farther away from each other. There's a second point. Hit save, and then let's check our answer, and it's giving us credit for it. I hope this is helpful. If you have questions, you can send me an email, and maybe we can set up a Zoom session. Have a good day.